Welcome all of you to our Tech Talk, Industrial AI for Predictive Quality, with the very significant and interesting question, how to deliver projects that work. You may work in AI projects yourself and came across some obstacles or so. Today, we may shed some light at what to do better in terms of the future. And we have a very great speaker with us who I will introduce in a second. My name is Mark Harahan. I'm Program Director at KI Park, and on behalf of the KI Park team and the KI Park community, I welcome you all to this Tech Talk. My job is basically to connect people to work on AI projects. This involves talking about the right use cases, but also inspiring them on what is the right problem at hand to be solved, and then, of course, get the right team together to start solving them. If you are new to KI Park and this is your first KI Park event, what are we and what did you sign up for? We are a network of organizations and people that like working on AI and doing that for some while now. We help organizations to understand the problems at hand and whether AI is actually the right application for them. We set up new use cases and showcase what is already possible with it and how can you do it best. And of course, we are, and as a network, have the right partners in our ecosystem to align you and to connect you. But also learning is a key element of our activities, given that AI is so broadly applied and everyone is basically fighting the same battles. In our ecosystem, you can learn from other organizations how they approach AI, what a good AI strategy may be, and how a good transformation may look like. We ourselves are no consultant company. We are a community, and we have about 250 organizations now all working on AI. This involves startups, implementation partners, larger corporate who are having use cases, but also infrastructure to provide us data centers and some regulators even. So the entire ecosystem that is needed if a use case will make it to application. And given that these organizations are a community, here are some images about how life at KI Park looks. Actually, on Monday, we are turning 4 years old. We have our four-year anniversary. And yeah, we run about 80 events every year. We have about 10 expert groups, like closer communities within our ecosystem where people gather up about 3 to 4 times a year. So this is really a melting spot of getting engaged in AI and meeting the right people at hand. If you're interested in learning more about us, feel free to reach out to me. You can reach out to me with mark@kipark.de or just write me on LinkedIn or in this chat expo. I'm happy to tell you more about what we do. But today it's all about how to deliver projects that work. And before I introduce our speaker, there's 2 notifications I like to do. First, we're gonna record the session because we are usually sharing it afterwards within our community for others that couldn't make it to rewatch it. So this session is gonna be recorded, except of the Q&A session later on. We will stop the recording so you can freely ask your questions, no matter what they are. And as I'm talking about Q&A, there are 2 ways on how to approach this. The first thing is you can just simply use the text bar, the chat box, and write down your questions. We will read them out loud, and Aleksander or I are going to answer these questions. Or you also have the opportunity to raise your hand, and then we will unmute yourself so you can ask your question straight away. So either way, either write them straight into this chat box already while Aleksander is presenting, or note them down for yourself so you can ask them later on. And yeah, that's it. I think now it's time to introduce our speaker for today, Aleksander Fegel. Aleksander Fegel studied computer science and business, so has a background in both of things. And 10 years ago, I think even more than 10 years ago, decided to found Ailio with his team. Ailio is a implementation partner. It's a AI-focused organization that has already delivered more than 100 projects in various domains, so bringing a ton of expertise on tackling this question, how to deliver projects that work. And yeah, I'm very happy that you are here with us today. You are operating not from Berlin, not from Munich, not from Frankfurt, but from Bielefeld. So having a very also regional touch point, and can probably share some stories about how AI is being executed, not in these main hubs, but rather in the areas, of course, where you are active. So very glad to have you here today. And yeah, looking forward to listen to your presentation today, Industrial AI for Predictive Quality. Thanks, the pleasure. Go ahead, the stage is yours.
Thank you very much, Mark. Yeah, Bielefeld does really exist, if somebody is asking himself the question right now. It's a bit of a running joke here in Germany. All right, so I will share my screen and we will dive right into it. So today, what can you expect? We will talk a bit about what defines an industrial AI project really, and how is it different maybe from classical software projects or data projects. We will look into one specific industrial AI use case that we did with a customer of ours. I will try to give you a lot of insights to that. Obviously, we cannot share everything and all the details, but we have the permission to share a lot of interesting details. So I will show you the results that we have, the challenges that we had, the approach from a methodical way, and the technologies that we used. And I think this will already be a good view behind the scenes for the use case. We will do a small lessons learned from the use case, and I will try to outline from all the projects that we did, what we learned, how it works well to deliver projects. And all in all, I want also to help a bit to translate words into actions. So how to not only talk about cool ideas and possibilities, but how to also get started and make the first steps, because they are usually the hardest in most things in life. All right, so let's start off this whole thing with a question that seems a bit off maybe, but I will get my point soon. And this is, what defines a startup? And the reason why I ask this question is because I think startups and industrial AI projects have a lot in common. And if we understand this, we might be able to approach them with a bit of a different mindset. So for me, there are like 2 or 3 things that really define a startup. This first thing is that usually you have an idea, a vision at the start when you begin. At example, we want to build a platform to rent out houses. And what usually happens in all startups is that the initial idea and the initial vision is not 100% the solution that you need at the end. So you iterate, you change your product, you change your market, you change your idea and your vision until you find a product market fit. And if you have achieved this, you have basically already won. Most startups fail while doing this. So this is one thing. And out of this, the result is that an investor who says, I want to invest into a startup, they usually don't only invest into the idea because they know it will iterate and it will change. They usually invest in the persons and believe these guys are able to find a product market fit somewhere in this market around this vision and idea. And if we look into AI projects, they are very similar. The initial question and the goals usually adapt a bit along the way, because at the beginning, we usually don't have a very good picture of how the data looks like, what's the quality, what hidden problems are laid out there, and what challenges in the process and so on will appear. All of these things usually appear while actually working on the project and asking questions and reviewing results. So we basically already most of the times know that we might need to adapt our initial vision, our initial goals a bit along the way to achieve something that can actually create value and basically make money with data for the company and for the customer or for the industry. And many insights are actually derived from doing. Like in a startup sense, I think nobody is these days building startups anymore with sitting 3 years in the cellar and writing down a cool concept of 300 pages and then building it, and then it's a successful business and you can do an exit and go to rent. But usually you just start close to the customer, you try things out with a small POC, you get feedback, you get results, and then you learn from it and build on it. So this is also very similar here. All the insights that are actually gained and all the problems and all the adaptations that are needed inside of an AI project in the industrial AI sector, they can only be made visible if you actually start doing things. Otherwise, they will usually be hidden. Right, and at the end, an investment into data and AI projects is usually combined with some uncertainties and some risks. So usually you need to believe in the team, in the persons that are executing it, in the internal team or in the partner, that no matter what challenges they will face around the project, they will find some solution and will find a cool data product at the end of the day that they can achieve. So that being said, as a small initiation to the topic, I want to dive into something less theoretical and more practical. So the use case that I'm showing today is something we did together with Ingredion. Ingredion is a food company. They are actually doing not food by itself, but ingredients for food that are necessary to achieve specific attributes. So they don't make the cookie, but they make that the cookie is tasty. Let's call it like that. And they are international business. They have factories and business operating around the world, from US to Germany to Thailand and so on. We started mainly with the factory in Hamburg as a kind of innovation hub for us, but currently have rolled out over 10 industrial AI projects all over the world and currently working on it. So it's growing a lot currently, but we started out in Hamburg, and that's our base point of contact, and that's how like the factory looks like in Hamburg. So you have a small view. And you can see at the factory, at example here, that they have big containers. And you can imagine that in these containers, they are cooking tons over tons over tons of starch, at example, and doing specific chemical things with it to achieve attributes and specific goals, and have products then in the specification that they need. So when we started with Ingredion at the very beginning, the question that we have set out is, can we optimize our processes using historic production data? So they had a base situation which is very similar for all industrial customers that we have. They have some Excel sheets, which is like laboratory data where people maybe entered stuff into sheets and it got scanned afterwards and digitalized, where maybe Excel sheets were maintained over the course of time. They have sensor data from the machines to some degree available. They have order data, ERP data that might be relevant for the production process, and. So there are a couple of scattered data sources, and a lot of the data is actually produced by hand, by humans in a manual way, which is not the best way to have data produced, probably the worst way, because obviously it's then very tied to how the human behaves on a day-to-day basis and very easy to have errors. Like if you make a test and have to enter it at an Excel sheet at the end, a lot of things can go wrong, already starting with simply forgetting what was actually the result and just entering something that you somehow remember. All of these things can happen and cause bad data quality and data that we don't understand why it is the way that it is. So how did we kick off this whole thing? Usually we, obviously it's not rocket science, but it's very important from my perspective. We usually start with a prioritization workshop, because I always believe, especially if an organization is a bit immature and just starting with these kind of projects, the first things that you do need to be a winner. You need to convince your employees, your factory workers, your management, and so on, that it's a good idea, that it's worth the risk, that it's worth the money. And if you commit to a project that takes a lot of time and maybe doesn't have a lot of impact and maybe is very complex and never goes to production, then you will probably fail the topic and lose a lot of time for your company to actually have great results. So I think deciding for the right things to do at the beginning is a very good and important method. And it's a bit like in sports. You have a lot of sports where you make in German you could call it Aufschlag, a starting point for the match. And this basically defines how the rest of the match will go. So here, for us in the prioritization workshop, it's usually about understanding what are the different ways and options that we can go, that we rate them. Usually you can do this with an ICE framework, that you say what's the impact that we have here, what's the ease, how easy can we do it, and how much confidence do we have in it. And then you can start clustering your use cases and ideas and approaches and filter it down to where you have the possibilities with the most interesting spectrums. And usually in this early phase with a workshop and POC, I highly recommend that you have few people involved, maybe one expert on the production side, one expert on the industrial side, maybe one technical expert, which should be an all-rounder. So don't take a data scientist, a data engineer, an MLOps engineer, a project manager, and in for a POC workshop phase, but rather one or two all-rounders that can build end-to-end use cases and have the communication centered around them, because that makes projects way more efficient. And one thing we learned is that the more things you can try out in data science and AI, and the more you can experiment, the more the chance is that you find the right use cases and the right ideas, and that it will send signals that it works. So reducing the cost that you need to do a workshop, to do a POC, to try things out, the easiest way to do this is to have few people involved, and preferably all-rounders that are maybe not the absolute best experts in the world in the one topic, but that can build basic end-to-end use cases and try out ideas. So that's something that we, especially at the beginning of projects, very much approve. And basically our advice is also let the people speak together. So the data scientist who builds the use case should directly speak to the industrial AI worker, the person who owns the process, the person who creates the data, who is responsible for what's in the sheets, what's in the database, and so on. If you have a lot of communication in between, because you only speak with his manager and he speaks with them, a lot of important context is always missing, and that leads to projects simply failing or not being successful due to the data scientist not understanding the whole picture. But I will dive deeper into this a bit later. So that being done, we decided for a couple of use cases and ideas that we want to approach, and jumped into a rapid prototyping phase. And before I go deeper into this, I want to quickly outline what we actually want to do here as our first use case with Ingredion. And basically, you can imagine that at the factory, at Ingredion, there are machine runners who basically decide this machine runs 50 minutes now, this machine runs 40 minutes, this machine runs 80 minutes, and so on and so on. And these decisions are basically based a bit on some Excel sheets, some work experience, some stomach feeling. And basically, the goal is always to have the shortest possible time that you run the production cycle, but obviously with a success, so with a product that is in a specification. And the runs are always a bit different because the machines are different, the input material is different, the recipes are different, the pressure, the heat, the surroundings are different. So it depends a lot on a lot of factors, how long you need to run this production cycle to be successful. And basically in the past, it was always done by humans based on the decisions that they made. And our goal here was, can we create an AI model that predicts the shortest possible time to run each cycle with always having a successful product. So basically, having a product in the specification obviously not failing, because you don't want tons of starch to have failed and be overcooked or undercooked and so on. This would cause some trouble. And our hypothesis was basically that the plant operators would tend to be more defensive, because obviously they don't profit a lot if it's 5 minutes shorter. But they don't profit a lot if it's 5 minutes shorter, but if it's undercooked or overcooked, it would be problematic. So they rather make sure that everything goes right and not that everything goes most optimal. And the second hypothesis that we had is, if we manage to have very accurate predictions and a very good model that creates successful outcomes and shortens the time, or is shorter than the operator in average, we can create a lot of business value, because we can produce more with the same plants, and we can reduce the energy consumption and so it would have a lot of benefits here. And in this rapid prototyping phase, where we basically got thrown over some Excel sheets, some laboratory data, some sensor data, some exports and so on, without a lot of infrastructure, without a lot of automation, the challenge is always to find the right tool for your problem. So obviously everybody talks a lot about generative AI currently and AI chats and so on, but especially in industrial setting, often this isn't even so interesting at the end of the day, but you rather deal with machine learning, neural networks, and deep learning to solve problems. Sometimes obviously generative AI can also be an exciting tool to solve a problem. But what I want to outline here is that a good data scientist, a good all-rounder, has a broad availability of tools at his disposal and a broad knowledge, and he is able to try different things out and find the right tool for the problem that he is currently facing and the data that he is currently facing. So a goal of the rapid prototyping for us, and one mantra that we have, is always make data science touchable. Because at the end of the day, you usually talk about data and KPIs and so on, and have some PowerPoint slides and talk about accuracy and all this stuff. And a lot of people cannot really understand this in detail, and it's not really touchable for them and understandable, and they don't get very excited about it at the end of the day. If the data scientist says, I have managed to edit 2% to the accuracy and it's now 91 instead of 89, most people will not really comprehend what that means and why it's cool and so on. So one mantra that we have is that in the rapid prototyping phase, if we start experimenting and so on, we actually also always develop like a web application with Streamlit, which is a framework, Python framework that we use to rapidly set up small web apps. And here you see at example the model predictions. You can set different parameters. You can set different products, recipes, and options on the left side. And then the model predictions would change. And you can actually start deep diving and experimenting with the model, with the data. And at example here, you see the red line, what the operator has set in the past. And the purple point is what the model would have predicted, and basically the delta is basically the delta between them is the time that we could spare in the process. And also, what are we predicting here? We are predicting different attributes like the viscosity and the rise that are important. And basically, to keep it a bit vague, I need to keep it a bit vague. If specific points and actions are met in this chemical attributes, then the product is done and we can finish the cycle. So predicting this correctly basically means that we know when we are finished. And basically there's no other way really than predicting it, because a laboratory test to actually check what's the viscosity right now takes too much time. It wouldn't make sense to make because it takes like 10 to 15 minutes. So it wouldn't make sense to actually check, are we done? That's not possible. So we need to predict it with AI. I hope that makes sense for you guys. So this is another chart from the prototyping. So here we have a rough estimation of how much time we could spare. If we, this is in one batch of a day, different processes that run. And here you can see in some processes we could have spared 5 minutes with the delta between the operator and what we predicted. In some batches, we could even spare 25 minutes. So this is like the first signals. And we saw when we compared the historic data and the historic results to our predictions, that we already were right a lot of times, and we saw that we can spare time here. So from the rapid prototyping here, our impression was the use case sends signals that it will work, that we can create a lot of business value, and that we can actually make this successful for Ingredient to earn a lot of money with it. So the key takeaways for the rapid prototyping phase for us are always: do not initiate an IT project. Usually you will find out a lot of problems inside the project, and if you say, oh, but we need the platform and the right data and so on, you usually create big IT projects which take 2 years, and you never actually start the use case, or maybe in 3 years, in 4 years, and then if you actually start it, you will uncover 10 new problems that you didn't even know about, and you can push it back again 2 years. So this is how it happens that 6 years nothing happens. So usually we start with rapid prototyping to just throw over some exports, throw over some data, let's experiment quickly, and let's see if something sends signals that it might work. Cool. Obviously, later on we need to do things properly, but this is how we usually do a first investigation. Poor data quality is standard. We have never met a use case in the last 10 years where we came to a customer, we had a setting and said, wow, cool, the data quality is great, we can make a great result immediately. Usually you face a lot of problems, and it's actually the work of a data scientist, from my perspective, to solve these problems as good as possible. Obviously, a company needs to improve their processes, improve their data, and so on, to have a better base. But if you always immediately give up, if you see the data quality is not optimal, you will probably never bring something to production and never achieve something. From my experience, I'm always talking just about my experience. So we usually have the mantra that we try out all the ideas that we have, but we also need to recognize when we give up and say it doesn't make sense at the moment, we need to step back, make a new process, gather the data in a new way, have new sensors and so on, because the baseline currently is just not trustable. So this is a fine line where a data science team moves, and where it's sometimes a hard decision where you say, do we continue for 1 more month, burn more budget and try to make it work? Or do we say we make a cut, we try something else for now, and we give the feedback what needs to change to have better data for now? So this is sometimes challenging, and this is what makes a senior data science team to make these decisions properly and in the best way for the company. Also, as I said at the beginning with the startup introduction that I did, we have a mantra of be open to rethink and relearn of what you actually are doing, and to change maybe the goals a bit to always create business value. So that something does not work from the beginning because of poor data quality does not necessarily mean that you cannot create business value. At the end of the day, we often find side projects, side goals, and side ideas which we passively can achieve, and where we can say, hey, we did not immediately solve the whole use case and have the perfect solution, but these 3 things improved now. That's already worth the money that the company invested, and we now know what we need to improve with the data and the processes to make the big goal also achievable. So no matter if you are external, a consultant, or internal data science team, I think this is a very good approach to actually tackling challenges, to always try to create business value and make the project phase that you currently worked on count and have a value and not a throwaway. So this will actually make data science teams successful in companies from my point of view. Because usually they need to justify a lot of their work to management and so on, and if it's really working and creating value, and if you have this mindset, I think it's much more likely that you are successful. And as I already initiated in the workshop phase with the direct communication and lot of communication overhead, a close contact with domain knowledge experts for the data science team is absolutely crucial from our experience, especially in this rapid prototyping phase. Often it was one sentence or one word or one hint from a domain expert which actually made a project work which was undoable for 1 or 2 months. So having these close contacts, regular exchanges, quick feedback on questions for the data and so on is extremely crucial from my point of view. Right, so also hands-on data science visualization is key. If you actually give the domain experts tools that they can touch, that they can try out, where they can give feedback, if you work close to the customer, if in an agile manner, back to the startup phase, then you will have a buy-in from the operators, from the plant operators, from the domain experts, and this will actually make your project much more likely to be successful. We usually try to run ops first approach, so make everything already from the beginning with CI/CD, with infrastructure as code, end. So the proof of concept is not starting point that you throw away, but a starting point for the project and a good fundament that you then can build up and go on. And data is never a fact. At the end, obviously, there is the saying in Germany, probably also in English, the numbers don't lie. But in reality, the numbers often lie. And they need context, and they need to be questioned. And it's the main job of a data scientist to question the data that he has, if it makes sense, if he can trust it, if it's outliers, and. So that's important to understand from my point of view. Okay, now we have done a lot of Wilder Westen, we call it in Germany. A lot of we try things out, be quick, we create a lot of dust setting up and so on. And everybody is a bit, oi, 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 everything is going so quick. And now we have a use case here that sends us signals, like we think it works, we think we have somewhat the right data, we think we can make this production ready. And now the real work actually starts. So now we take a step back and we get into a data engineering phase where we want to build data pipelines, where we want to automate things, where we want to get more data sources, and we want to build a more robust framework, and we want to prepare everything to be an actual MVP and be able to get operationalized. And this phase is a bit interesting because at the beginning, you will see a lot of progress as a stakeholder very fast. You will see a lot of new shiny stuff every week. And now we get into a phase where you maybe get a tech update every week, but not new shiny stuff every week. But this is absolutely necessary. So usually we work with Databricks here as a data platform, and then we build data pipelines and transformation and automation to actually have a running workflow, because nobody wants people exporting and shuffling and transforming Excel sheets every day for the use case to work. That's not so cool. It would remind me of one AI startup which went bankrupt because they had like low-code, no-code automation, and basically they had just 1,000 employees doing the work behind the scenes, and it was not actual AI. So we want to do things right in this space. So at example here, we then added a lot of sensor data, which allowed us also to do live corrections of the predictions. So if we realize something goes wrong on the live run, something goes in the outlier, we maybe add some time to not have undercooking or overcooking. We were able to add new features to the model and enhance it. And then after the data engineering phase, we go into the rollout, and actually we try to do this as early as possible. So I already told you, we built like a web app, we give it something to the customer, they already saw something, the domain experts who actually use it at the end. And now we want to actually roll things out that are possible to use in production. And we don't want to have the perfect solution here yet. It's absolutely okay if things fail, if things don't make sense, because we need this feedback. Because this is the most underestimated thing from my perspective. If you roll things out actually to people using it, a lot of new problems will appear. And if you do this very late, and you think, oh, everything is working now, cool, let's give it to the people, and then you have 100 complaints, and you might have no budget anymore to actually solve these issues. So giving it early to the customer and to the, I always call like the domain expert who actually uses it, that's the customer for me, and make them use it in production in the process to actually get better and gather his feedback and work on it. That's absolutely crucial to actually make this really operationalized and production ready. And I think one thing you can say, if we are here at this first rollout, you have done like 50% of the work. So if you are honest about budget and timelines and so on, you don't plan that this is the end of the project, but this is actually the second start of the project now, I could say. So the next steps are obviously that we release more recipes, that we improve this whole thing. At the beginning of an AI project, we maybe start with only a few recipes, only a few data points to make things simple and more, more calculatable. But now we want to grow the solution and make it more to an all-round solution. And then obviously operationalizing such a use case, you need to talk about downtimes, how automated is it, who relies on it, about SLAs, about MLOps, and all these things that are not fancy on a web app, but are crucial to actually make it work in production. And also, let's be honest here, I will show it later in the results of the project. An AI project that works on live data is never done, because the circumstances in which this data are created change every year probably in some way. And you need to adapt it, you need to learn from it, you need to make it better. So usually these are never projects which you set go running and then you never touch them again, but you need to be ready to actually have maintenance, ongoing maintenance and ongoing feedback here from human experts. Otherwise, this project will probably be out of sync at some point and not work properly anymore, especially in an industrial setting. We have machine learning models which are working since 3 years and we never touch them and everything creates value and it's fine. But this is not the usual case. The usual case is that things go sideways and you need to deal with it on a regular base. Here's a small architecture page, just to have a quick view. In a factory setting, you often work with edge devices because in some use cases, we actually run machines based on live predictions. And obviously for that, you want to have a low latency and so on, but you will, as a developer, also want to have cloud services to be able to compare models to work properly and efficiently. So often we find a situation in an architecture situation where you have a combination of edge services and cloud services, maybe also a demilitarized zone and so on, to actually make this running. Obviously, there are a lot of ways to implement this with different cloud products and different approaches. Our usual way is to work with Databricks, but obviously that's not the only way. That's just the way that we have learned and like for different reasons. Now let's deep dive in some final results or in-between results. As I said, nothing is ever final in these kind of settings. And you can see here, I will try to explain the chart a bit. You can see different recipes. This is like the y-axis are the different recipes. And you can see the orange is basically the data points after we have started using the AI model. And the blue is the data points before we have started using the AI model. And the y-axis is the timeline here. So basically, the lower the point is, the shorter we made the run. And basically, our goal would be to, in average, be lower than before in the data points. And what you can see here, and I always try to be very honest, you can see that for some recipes, it works very well. An example here, in this recipe, or here in this recipe, or here in this recipe, we were able to spare a lot of time. In this recipe here, we were able to centralize it more, and we were able to also, in average, spare time, because some of the outliers here were actually failures and not running properly, or undercooked or overcooked. So we were also able to improve the quality. You see here an example of things not improving. And that's for two reasons. First of all, each of these recipes are basically checked for performance. If they are actually, if the performance is good enough to use the model. And for some recipes, it's not good enough, so we don't use it. We fully rely on the manual work further on, because Ingredion has like hundreds of recipes. And at the end, a lot of them are not cooked very often. We don't have a lot of data points, so there it's very hard to make good predictions. But for the recipes with a lot of traffic, we obviously have the best predictions. and they create then also the most impact. Here, what we had is a classical scenario of things going wrong because a project team basically changed the machine and some parameters and so on, but we never talked about it. The data science team did not get to know this, so the data was completely different suddenly, and the model was not giving good estimations anymore. And then we investigated it, and we found out, hey, something changed in the actually hardware and in the production, and we would need to retrain this and rethink this and make new data here. And this is also like an important learning. You need, if you run these kind of projects, you need to talk also about processes, about communication in the company and, because these kind of things obviously create production problems otherwise. And depending how critical, like this use case here, at the end, still a human decides what he puts into the machine. Like the model says 40 minutes at example, and he decides, does he take it or does he not trust it and take something different? Usually he trusts it in the meantime. But for other use cases, we have a full automation where live predictions are made and the machine does actual things and changes parameters based on predictions. And obviously you have need way more accuracy here in these kind of use cases. So the business value for Ingredient was here in the specific use case that we were able to run the process 5 to 10 minutes shorter in average than estimated by the plant operators. We successfully run this in production, in operations. We basically don't have any failures till now of overcooking or undercooking, and we can increase the plant output by 4 to 7%. And make 6 to 7 figure profit per year additional per factory who is using it and running it properly, with a use case which was like a half year to a year of work of like one person. So I think that's also a very nice example of how data products can actually have a really nice, great impact in an industrial setting, even if you don't have a 10-person team working on it for many years. Exactly. And also there are some synergy business values which are not listed here. For example, all the other use cases that we are tackling basically also profit from the knowledge that we have built up here and the platform and the data infrastructure that we have built up here. So we basically make future projects shorter, faster, and so on. So this spares also a lot of money and time to market and whatever you can write on the slides. And some lessons learned from this case, and I'm going to the finish now, and we can answer some Q&As. So if you have questions, you can already put them in. First, always establish cross-functional team projects. So we need domain experts, we need the technical experts, and we maybe need a visionary who can actually also give the business view, how much effort can we put into it so we still have value. Obviously, you need to also understand how much money the use case can make the company, because if you make a use case with 2 persons for a year, which spares 1 hour of work for 1 person in a year, like an extreme example, it would be bullshit. So understanding how much fuel you have to actually try things out and it still is worth it is also super crucial for a project team. Small team of all-rounders and domain experts, especially at the start, are very helpful. And usually with AI project, it is that you can make the 80-90% solution quite fast in maybe a couple of months or half a year or a year at maximum. And then every % additional value becomes exponentially more expensive to achieve. So often, like a good solution makes way more sense than a perfect solution from a business perspective. So you can often just keep it to the small team of all-rounders for a very long time or forever. But sometimes if you have a use case with a lot of business value and a lot of budget, you can also obviously make a big team with very specialized people in this topic and try out more crazy things. One learning that's not here is also often the problem is in the data and understanding the data and the processes and the domain knowledge, and not actually in the frameworks that we use. So often the most simple algorithms solve the problem very well if you have the data properly understood and prepared for it. So you don't need the craziest papers from a Chinese doctor to solve a problem usually, but you need the data understood and prepared properly most often. Short communication channels are essential. The people who are the domain experts need actual time for the projects and not do it as their 60th overtime hour. You need some willingness to risk a bit of projects, maybe not immediately achieving the full business value. Short iterations and salami tactics, which we call short project phases with clear output and so on. And a bit of a nothing is impossible mentality. And then you can deliver projects that actually work. And maybe to close my talk, one attendee of the talk that in an earlier time said to me at dinner later on, hey, today I learned that I need to convince my CEO to invest in AI without a business case. That was his learning from the startup thing that I told at the beginning. That's obviously not the message. You start with a clear business case, with a clear goal, and with things that make sense, but you should be open to adapt on the way and be agile. Otherwise, you might never be happy and find the right things. All right, that's it from my side. Mark, you already are visible again.
Yes.
Do you have anything that you want to add or ask? Otherwise, I would try to look in the Q&A.
Thank you for the questions and thank you for your time, Alexander. And this is not the end, this is the start. We are regularly doing activities and events. One is happening, which I'm happy to announce now. We are doing a physical AI expert group focusing specifically on industrial and robotic use cases out there. We are currently setting it up. So this is basically a teaser at the moment. There are two things you can do. You can either scan the QR code or you can directly reach out to physicalai@kipark.de. And if you reach out to that email, we will keep you posted on the launch of the expert groups and how to get involved and when we are starting the kickoff date. And as I said, we are doing about 80 events every year, focusing on very different topics out there. And if you don't want to miss any of this is the newsletter QR code for you, which you can scan, but there's also going to be some follow-up information afterwards. So you don't miss any further tech talk or some further activity and event that we are doing either in Berlin or maybe at your doorsteps. And I would like to close with, of course, another invitation. Get involved into this community. It's a lot of activities you can do. It's the projects, it's the expert groups, it's the events you do. But it's more also about stepping into that mindset and meeting the right people that are all forward thinkers and are very exciting about these AI developments happening at place. So thank you for making the time today and for investing 1 hour in learning about what a good AI project means. Thank you for your time and have a successful rest of the week.
Obviously, if you have further questions, I can share my LinkedIn in the chat quickly. We can follow up on it there. So we don't stretch the meeting for too long. And thanks for the opportunity to join here and do the small talk. I hope you guys had some nice impulses to approach things differently in the future or learn something from it. Otherwise, if you see things differently or thought it's all bullshit what he said, then just write me and explain it to me, and I'm happy to learn also. And yeah, thanks for being part of the community.
Awesome. Have a great day. Thank you. Bye-bye.
Bye.